Welcome to electricalworld360.com. In this video, we are going to solve the MCQs of single phase motor. That means a single phase induction motor. And this is the part 3 video of this series. So before we start, if you are new to the channel, then please subscribe our channel, and if you want, you may follow us on Facebook also. We are also available on Telegram, and usually whatever video I make, I used to upload all the PDFs in this channel. So if you want, you may join us on Telegram. To join our channel, you can simply search here Electrical World 360 official, and otherwise if you want, you may join us through this link also. So this is the question number 1. A single phase induction motor employs dash rotor, squirrel cage, wound, either squirrel cage or wound, and the option number D is none of the above. So here the right option will be the option number A, that means the squirrel cage rotor. A single phase induction motor employs a squirrel cage rotor. This is the question number 2. The most of single phase induction motors are dash machines. 2 pole, 6 pole, 8 pole, 4 pole. So these are the options. So here the right option will be the option number D. That means the most of the single phase induction motors are 4 pole machines. This is the question number 3. The main winding and starting winding of a single phase induction motor are connected in series or series parallel across the supply. So here the right option will be the option number B. That means the main winding and the starting winding of a single phase induction motors are connected in parallel across the supply. This is the question number 4. The starting winding of a single phase induction motor has dash that of the main winding. That means these are the options. So here the right option will be the option number C. That means the starting winding of a single phase induction motor has the same number of poles that of the main winding. The number of the poles will be the same for the both cases. This is the question number 5. A 50 Hz 4 pole single phase induction motor will have a synchronous speed of, these are the options. So as we know, the synchronous speed means the NS. NS is equal to 120 F by P. So here we can write it like this way: 120. We have to find out the NS, that means the synchronous speed. So 120 into F. F means the 50 Hz by P. P means 4 pole. The number of poles is 4. So after solving that, we will get 1500 RPM. So here the right option will be the option number A. This is the question number 6. A 4 pole 50 Hz single phase induction motor has a slip of 5%. The speed of the motor will be, these are the options. So as we know, the NS will be 120 F by P. NS means the synchronous speed will be the 120 F by P. So you can write it like this way: 120 F is 50 and P means the number of pole is 4. So after solving that, as like the previous one, we will get 1500 RPM. So here we have to find out the speed of the motor. That means, as we know, the formula of slip is S means slip. Slip is equal to the NS minus N by NS into 100. So we can write it like this way: 0.05. Slip is 0.05 because here you can see the slip is 5%. So we can write the 5% as 0.05 is equal to NS is 1500, and we have to find out the N, that means the speed of the motor, and by NS is 1500 into 100. So after calculating, we can find out the N easily. So N is equal to 1425 will be the right answer. So 1425 RPM will be the right answer. So here you can see in the option number B is the right answer. This is the question number 7. A single phase induction motor speed sensitive centrifugal switch is connected dash winding parallel with main, series with main, the parallel with starting, series with starting, and the parallel with starting. So here the right option will be the option number C. That means in a single phase induction motor, the speed sensitive centrifugal switch is connected in the series with the starting winding. This is the question number 8. The purpose of starting winding in a single phase induction motor is to reduce losses, limit temperature rise in temperature of the machine. Option number C is the produce rotating flux in conjunction with the main winding, and the option number D is none of the above. So here the right option will be the option number C. That means the purpose of starting winding in a single phase induction motor is to produce the rotating flux in the conjunction with main winding. This is the question number 9. If Im and Is, here the Im is the main winding and the current of the main winding, and the Is is the current of the starting winding. So Im and Is are the currents in the main and the starting winding of split phase induction motor respectively, and alpha is the angle between the Im and Is. Then the motor torque is T is given by, so here which the formula is the right answer, which will be the right answer. So here the option number B will be the right answer. That means T is proportional to, that means torque is proportional to Im, that means the current of the main winding, into, that means multiplied by the Is, the current of the starting winding, and the sine alpha. That means what is the alpha? Alpha is the angle between the Im and the Is. This is the question number 10. In the resistance split phase induction motor shown in the next figure, the main winding has, so this is the figure and this is the centrifugal switch, and this is the starting winding, and this is the resistance, and this is the rotor, and this is the main winding. Okay, so you can write it like this way: the I is the incoming current, and this will be the Im, and this will be the Is, and this is the input voltage. So here in question you can see the resistance, in the resistance split phase induction motor as shown in the next figure, that means this figure, the main winding has the high resistance and the high inductance, the high resistance and the low inductance, the low resistance and the high inductance, and the option number D is low resistance and the low inductance. So here the right option will be option number C. That means the low resistance, high inductance will be the right answer. So this is the question number 11. The resistance split phase induction motor is used for the low inertia loads, the high inertia loads, very high inertia loads, and the option number D is none of the above. So here the right option will be the option number A. That means the resistance split phase induction motor is used for the low inertia loads. This is the question number 12. The direction of split phase induction motor can be reversed by the interchanging the connections of supply of either main or starting winding, the both main and starting winding, and the option number C is the rotor winding. Option number D is none of the above. So here the right option will be the option number A. That means the direction of split phase induction motor can be reversed by interchanging the connection of supply of either main or starting winding, connection of supply winding of either main and starting winding. This is the question number 13. The resistance split phase induction motor has high, moderate and low starting torque. Here the right option will be the option number B. That means the resistance split phase induction motor has the moderate starting torque. This is the question number 14. The resistance split phase induction motor is used in those applications where the starting is frequent, the starting period is long, the starting is infrequent, and the option number D is none of the above. So here the right option will be the option number C. That means the resistance split phase induction motor is used in those applications where the starting is infrequent. This is the question number 15. The resistance split phase induction motor are most popular single phase induction motor because of their low cost, their high starting torque, the long starting period, and option number D is none of the above. So as we know, here the right option will be the option number A. That means the resistance split phase induction motor are the most popular single phase induction motor because of their low cost. They are very cheap. The price of their cost is very low. This is the question number 16. The value of Is in capacitor start motor as shown in the figure is dash the current of Im. So this is the figure. Here you can see this is the centrifugal switch, and this is the starting winding, and this is the capacitor, and this is the rotor, and this is the main winding. So the value of the current Is, that means this will be the I and this will be the Im. The current which is flowing in the downward, this will be known as the psi S. So the value of current Is in capacitor start motor, this is the capacitor start motor. Here you can see the capacitor as shown in the next figure is dash the current Im. So this will be the current Im, current towards to the main winding. So here these are the options. So the right option will be the option number B. That means the less than that of. That means the current Is is less than that of Im in the capacitor start motor. And if you are preparing for SSCJ, then there is a course for you, the 60 days online course, and the price of this course is only 599 rupees. And in this course you will get the 6000 plus MCQs with the video solutions. That means solution will be provided to you in the form of video, and along with that you will also get the important notes for the GK, that means the general knowledge and the general awareness portion, in the form of PDF. Okay, so if you want, you may enroll on this kind of course, and so many students have already joined in this course. So if you want, you may join on this course. The price of this course is only 599 rupees only. So this is the question number 17. The capacitor C used in the capacitor start motor shown in the next figure is always dash capacitor. So this is the figure. Here you can see this is the capacitor. So this will be always the paper capacitor, ceramic capacitor, mica capacitor, and the option number D is the electrolytic capacitor. So as we know, the option number D will be the right answer in this case. The capacitor C, here you can see in the capacitor start motor as shown in this figure, always a electrolytic capacitor. This is the question number 18. At starting the line current at a capacitor start induction motor is dash, that means these are the options, the normal full load current. So here the right option will be the option number B. That means at starting the line current of a capacitor start induction motor is 4 to 5 times normal full load current. This is the question number 19. The capacitor run motor dash winding is cut out after starting. Here the options are, you can say starting winding, main winding, neither starting or nor main, and the option number D is option number none of the above. So here the right option will be option number C. That means in capacitor start capacitor run motor, the neither starting or nor main winding is cut out after starting. This is the question number 20. A capacitor start or capacitor run motor has the low power factor, high power factor, low efficiency, and the option number D is the high starting torque. As you know, here the right option is option number B. That means the capacitor run motor has the high power factor. This is the question number 21. The capacitor start and capacitor run motor is used in those applications where the high starting torque is required, the silence is important, the noisy operation is not important, and option number D is none of the above. So here the right option will be the option number B, as we know. That means the capacitor start and capacitor run motor is used in those applications where the silence is important. Okay, so that's why here the option number B will be the right answer. This is the question number 22. The capacitor run motor has the no centrifugal switch, low power factor, noisy operation, low efficiency. So as I told you in the previous question, here you can see the silence is important, so that's why you can easily say that this option is wrong. So here the right option will be the option number A. That means the capacitor start or the capacitor run motor has the no centrifugal switch. This is the question number 23. The capacitor motor dash resistance split phase induction motor. That means the capacitor motors are costlier than the split phase induction motor, and these are the other options. Are less costlier than the split phase motor. The capacitor motor cost about the same as the split phase induction motor, and the option number D is capacitor motors have poor starting torque than the resistance split phase induction motor. So as we know, here the right option will be the option number A. That means the capacitor motors are costlier than the resistance split phase induction motor. This is the question number 24. The most of the travels of single phase induction motor are traceable to the rotor brush, main winding, shaft bearing, and the option number D is starting switch. So here the option number D will be the right answer. That means the most of the travels of single phase induction motors are traceable to the starting switch. This is the question number 25. The single phase shaded pole motor has the squirrel cage rotor, the wound rotor, the high power factor, the high starting torque. So here the right option will be option number A. That means the single phase shaded pole motor has the squirrel cage rotor. This is the question number 26. The direction of rotation of shaded pole motor depends upon the supply frequency, the number of poles on the stator, which half of the pole is shaded, and the option number D is none of the above. So here the right option will be the option number C. That means the direction of rotation of shaded pole motor depends upon the which half of the pole is shaded. This is the question number 27. The full load efficiency of a shaded pole motor is about 7 to 80%, 60 to 70%, 30 to 35%, 5 to 10%. So in this case we should know the shading coils are not opened after the motor is running at the normal speed. So that's why the considerable power loss takes place in the shading coils. For this reason the efficiency of the shaded pole motor is very low. That means 30 to 35% will be the right answer. That means here the option number C is the right answer. This is the question number 28. The single phase series motor can operate on AC only, DC only, both AC and DC, and the option number D is the none of the above. So here the option number A will be that means option number C will be the right answer. That means the single phase series motors can operate on both AC and DC. That means whenever it is used on the DC, the single phase induction motor will be known as the universal motor. Right, as we know, the DC series motors are also used as that means the DC series motors can be operated on the single phase AC motors also. So in the case of AC, when DC series motor runs under the AC supply system, that motor is known as the universal motor. So that's why here the option number C will be the right answer. This is the question number 29. The vacuum cleaner employs dash motor. That means that these are the options: resistance split phase, capacitor step, shaded pole. Option number D is single phase series. So here the right option will be the option number D. That means the single phase series motors will be the right answer. That means the in vacuum cleaner employs the single phase series motor. This is the question number 30. For the same rating, a DC series motor cost about the same as the single phase series motor, are more than, less than, and the none of the above. So here the right option is option number C. That means the less than. That means for the same rating, the DC series motor cost is less than the single phase AC series motor. Okay. So this is the question number 31. The washing machine generally employs dash motors: single phase series motor, resistance split phase, shaded pole, hysteresis motor. So here the right option will be the option number B. That means The washing machine generally employs the resistance speed phase motor. This is the question number 32. The least expensive fractional horsepower motor is dash motor, the shaded pole motor, capacitor start motor, the split phase motor, AC series motor. So here the right option will be the option number A. That means the least expensive fractional horsepower motor is the shaded pole motor. So this is the question number 33. A 4-pole 50 Hz single phase induction motor is running with a slip of 3.4%. The speed of the motor is what? So as we know, the synchronous speed is equal to, that means ns is equal to 120 f by p. So here we can write it like this way: 120, f is 50 and p is 4. So after solving that, we will get 1500 rpm. This is the synchronous speed. So here the speed of the motor is what? So as we know, the slip s is equal to the ns minus n by ns. So here the ns is 1500 minus n. So we have to find out the n. So s is equal to, that means slip is equal to the ns minus n by ns into 100. There will be 100. Okay, we have to multiply this with the 100. So we have written here the ns is 1500 and we have to find out the n by 1500 ns and into 100. So after solving that, we can easily find out the ns because the slip is s is 0.4% is given, right? So we can write the slip like this way: 0.034 is equal to 1500 minus n by 1500 into 100. So now we can easily find out the n. So n will be, n is equal to, after solving that, we will get 1449 rpm. So here the option number C will be the right answer. Here is the question number 34. At starting the winding of 230 voltage and the 50 frequency, the split phase induction motor have the following parameters. The R is, for the main winding, the R is 4 ohm and the XL is 7.5 ohm. And for starting winding, the R is 7.5 ohm and the XL is 4 ohm. And the current in the main winding is what? So as we know, the current in the main winding, that means Im is equal to V by Zs. That means we can write it like this way: V is 230. You can see in the question here, you can see V is 230 voltage and Zs is, we can find out the Zs by this root over of 4 square, you can see here, R square plus the XL square, that means plus the 7.5 square. So after solving that, we can easily find out the Im. So Im will be 27 ampere. So here you can see in option number D will be the right answer. This is the question number 35. A 4-pole, this is the watt, this is the power, this is the voltage, this is the frequency. Capacitor start induction motor takes a full load line current of 5.3 ampere while the running at the 1760 rpm. The full load efficiency of the motor is 64%. So the slip is what? That means we have to find out the slip. So the synchronous speed, that means ns is equal to, as we know, 120 f by p. So as we know, we can write it like this way: 120 into f is here, frequency is 60 Hz. So 120 into 60 by p is 4, that number of poles, that means number of poles is 4. So we can easily solve this like this way. This will be 1800 rpm. m. That means the synchronous speed will be the 1800 rpm. So we can easily find out the sleep. So as you know, the sleep, that means S, I am writing here sleep. Sleep is equal to ns minus n by ns into 100. So here the ns is 1800 minus the n. So n is here the running at the, here you can see in the question, the 1760 rpm, that means 1760 rpm by n, that means 1800 into 100. So you can easily solve this. So after solving that, we will get the S is equal to 2.2%. So that is why here the option number D will be the right answer. So as I told you before, this is our course for the SSCJ candidates of 2019-20. So as you know, the situation of our world come India, so you can learn at home or learn from home. Okay. And I think this course will be so much useful to you. And in this course, you will get the 6000 plus MCQs with solutions in the form of video. And along with that, you will also get the important notes of GK or the general awareness in the form of PDF. And as you can see here, the price of this course is only 599 rupees. And here you can get this course, and this is a limited offer. I must say that this is a limited offer. So many students have already joined in this course. So if you want, you may enroll on this course also. And this course will be so much beneficial for this exam as well as other competitive exams like SSC, JEE. So if you liked our video, then please like us, and if you want, you may subscribe our channel. And thank you for watching our video.